All right, class, so this is your 6.4 recap video. Today we learned about intervals for variance and standard deviation. So first we're going to interpret the chi-square distribution and use a chi-square distribution table. Use the chi-square distribution to construct a confidence interval for the variance and standard deviation. First things we need to know is the point estimate for variance is s squared. So that's sigma squared, and we're not doing the population, we're doing a sample, so we're doing sample variance, so that's s squared. The point estimate for sigma is s, so that's standard deviation. So s squared is the most unbiased estimate for sigma squared. So variance is sigma squared for the population, and for a sample, s squared, and standard deviation, sigma, is population, and s for sample. And we are doing sample statistics, so we're going to be using s squared and s. You can use the chi-square distribution to construct a confidence interval for the variance and standard deviation. If the random variable x has a normal distribution, then the distribution of chi-squared equals n minus 1 times s squared divided by sigma squared. And that forms a chi-square distribution for samples of any size n greater than 1. Properties of the chi-square. All chi-square values are greater than or equal to 0. The chi-square distribution is a family of curves, each determined by the degree of freedom, to form a confidence interval for sigma squared. Use the chi-square distribution with degrees of freedom equal to 1 less than the sample size. So degrees of freedom is as it was in the 6.1 through 6.3, n minus 1 degrees of freedom. The area under the curve of the chi-square distribution equals 1, just like in the previous chapters. So here is the chi-square distribution are positively skewed, and here's some of the curves so you can see those with different degrees of freedom. Critical values for chi-squared, there are 2 critical values for each level of confidence. So chi-squared r represents the right tail, and chi-squared l represents the left tail. The area between the left and the right critical values is c, as we've discussed in previous chapters as well. Find the critical values chi-squared r and chi-squared l for a 90% confidence interval when the sample size is 20. So first we need to know our degrees of freedom equals n minus 1, which in our case is 20 minus 1, which is 19 degrees of freedom. Also our alpha in this case is 1 minus 0.9, which equals 0.1. So our lower left critical value can be found in Excel, and our upper can be found in Excel as well. So let's practice these. So I'm going to open up Excel, and we are going to do some of these problems. Now, when I look at their PowerPoint, notice that for the lower critical value, we do 1 minus alpha divided by 2, comma, degrees of freedom. So in our case, that's going to be 1 minus 0.1 divided by 2 with 19 degrees of freedom. So I'm just going to try to move this over here. So when we're looking at our Excel file, right here, I'm going to go up to our function wizard, find chi-inverse. So I'm going to type up in here, CHIINV. There's my chi-inverse. So my probability is 1 minus alpha divided by 2, in our case 0.1 divided by 2. And my degrees of freedom is 19. So when I push enter, you see that I get 10.1, which is the degrees of freedom that is shown here on the PowerPoint. To find the right tail, it's very simple. We just change. It is no longer 1 minus. So I still go to my function wizard, pick out chi-inverse, and my probability is 0.1 divided by 2, and my degrees of freedom is still 19. And there is my 30.14. So now, let's continue to the next slide. We are going to find the confidence interval. You randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation is 1.2 milligrams. Assuming the weights are normally distributed, construct a 99% confidence interval for the population variance and standard deviation. So, just like last time, first we need to find our degrees of freedom, which is n minus 1, and in this case it's 30 minus 1, which gives us a 29 degrees of freedom. P is 0.99, therefore alpha is 1 minus that, which is 0.01. Alright, so now I'm going to go back to Blackboard. I'm going to go into our course documents, Chapter 6. I'm going to go down here to my calculator, open it up. And notice when I'm looking at the calculator here, we have CIs for a mean, CIs for a proportion, and CIs for standard deviation. Well, in Chapter 6.4, we're doing CIs for standard deviation. So now I'm going to move this over here so that I can also look at my PowerPoint. I'm going to go back to my PowerPoint and make it small as well. And let's look at that information that they just gave us. So we have samples, 30 samples, so that is our sample size. Our standard deviation is 1.2. And now we need to find our critical values. That is what we just did. So we go up here, go to chi-inverse. I look at my probability here. It's 0.99. So for my lower critical value, I'm going to do 1 minus 0.01 divided by 2. And my degrees of freedom, 29. And I'm going to hit OK. For my upper, I'm going to go ahead and do chi-inverse again. And I'm going to just do 0.01 divided by 2 because I'm finding the right side, and 29 degrees of freedom. Now I'm going to type these in over here with 4 decimals. So 13.1212 and 52.3356. Now we have our lower limit and our upper limit. So if we go back and look at our PowerPoint, notice that's 0.89 and 1.78. We have just found the confidence interval for the standard deviation. So with 99% confidence, you can say that the population standard deviation is between 0.89 and 1.78 milligrams. We can also find the variance by squaring sigma. So if we square sigma, we get 0.8 and 3.18. Let me show you how to do this in Excel. So when we go back over here to Excel, if I want to square this number, I can just drag it over here, drag the number over here, go up here to the formula, and put caret 2, and that'll square my number. And notice I'll get 0.7979, which is also 0.80. So I'm going to drag this one over, square it, and I get 3.18, which is as I have on my PowerPoint. So now we can say with 99% confidence that the population variance is between 0.80 and 3.18 milligrams. All right, so when you use your CI calculator, this is the numbers that we found for this example. So that's our summary. We interpreted the chi-square distribution, and we used it to construct a confidence interval.